Okay, so what happens if we have an amine and an aldehyde? Well, it's going to depend on a couple things. First of all, the nature of the amine and the nature of the ketone. But let's just kind of start big picture. Let's say we have some ketone, and we have an R group, R prime group. To make it a little bit easier to see, let's do the amine in blue. For now, we're going to treat this as a secondary amine. Well, as you might expect, we have these lone pairs sitting on the nitrogen, and this is our negative source. And there's a positive on the ketone. And we can hit it. And what we would get as a first pass something that looks like this. Now, if we do this in the presence of the water or some type of nucleophilic solution, so something that like tetrahydrofuran or pyridine, which will accept the hydrogen off of this nitrogen, we can get the hydrogen abstracted by our solvent, and the hydrogen donated back by our solvent, to give us the alcohol. Now, if you have a secondary amine and you have both R groups being tertiary carbons, meaning that there are no hydrogens associated with those carbons, this is where the reaction kind of stops. We end up forming a tertiary alcohol adjacent to a nitrogen. Now, let's consider two scenarios. One scenario is where our R prime group here really has an accessible hydrogen. So we'll say R squared CH. Well, if that's the case, we've got this alcohol. What can happen is that we can further protonate we can use our solvent to further protonate this to give us H2O plus. This will come off. And via carbocation intermediate, we can get the hydrogen abstracted, and we end up with a carbon double bonded to a carbon. Well, we'll end up with an alkene plus an amine. So how would we describe this? Well, it was unfortunately, like when I started making this video, did I see how clever this naming scheme was. Originally, if we had an alcohol here, let's say we had an OH group here, we would call that an ene-all. The OL referring to the alcohol and the En referring to the double bond. Well, in this case, we would call this ene-amine. So ene for the double bond and amine for the nitrogen group being there. So if we have a hydrogen adjacent to where that alcohol is formed, we will get self-condensation or self-dehydration of the molecule to give us an ene-amine. Other scenario is, let's say it's not a secondary amine, but a primary amine. So instead of this being in R2, let's say that it's in H and R. So we're going to eliminate one of the R groups there on the amine, and we're going to make that into a hydrogen. Well, we're going to get a similar thing to happen. Our solvent here is going to protonate our OH group. It's going to pop off. We're going to go through a carbocation intermediate, and we're going to get hydrogen elimination to give us a nitrogen-carbon double bond. Oops. And this is going to be an imine. So, if we have an amine in the presence of a ketone, it will react with a ketone to form a bond between the nitrogen and the oxygen. Now, if the nitrogen is a secondary amine, meaning there's two R groups, and it's truly a ketone with no adjacent hydrogens next to it, meaning that none of these groups, R's have a hydrogen on them, we will finish up with a tertiary alcohol adjacent to a nitrogen. If there is an H on one of the adjacent carbons to the ketone, we will get condensation to give us an ene-amine or an amine. If there is a hydrogen on the nitrogen, meaning that is not a secondary amine but a primary amine, we will get elimination of the hydrogen in the OH group to give us a double bond between the nitrogen and the carbon, and this will produce an imine.